So number 41 from homework. On a stretch of interstate, a vehicle's tires range between 646 and 840 revolutions per minute. The diameter of each tire is 26 inches. 26 inches, all right? So the first question is find the range of values for the angular speeds of the tires in radians per minute. Radians per minute. So we go back to angular, all right? So angular is what? What's our angular speed? Theta over t. All right. In order to find theta, we have to do what with our revolutions? Change them into revolutions, right? And so what do we multiply them by? So to find theta, so we're going to start with the 646 first. We'll do this one, 646. All right. So my theta then is going to be 646 times what? 2 pi. What is that? Just in pi. 1292. So my theta here is going to be 1292 pi, and it's already per minute, and that's what it asked for in my question. So 1292 theta radians per minute. I'm actually done with that part of that one. Let's look at 840 revolutions per minute. What do I need to do with that to convert it to theta? Just times 2 pi, which gives me what? 1680 pi radians per minute. Now, if it were in minutes and they wanted in hours, I would have to do some conversions, right? But they wanted it in revolutions per minute and radians per minute. And so it's in the same units. I just have to multiply by 2 pi. So that piece of it is done. That is A. All right, let's look at B. B says find the range of values for the linear speeds of the tires in miles per hour. Okay, so linear speed, let's go to that guy. That formula is going to be what? What's my linear speed formula? S over T, all right? I need S. What is my formula for S? Theta times R. I need both of those to be able to solve this, okay? So for this one, I am going to take theta that I've already figured out, 1292 times R. They gave me the diameter. So what is my radius? This is the diameter. What is my radius? 13. 13. And I'm going to leave it right now. So this is going to be 1292 pi. 1292 pi times 13 over my time right now is still 1 minute.
Why is it 13 again?
Because my diameter is 26, I need my R. Take your diameter and cut it in half. Now in this particular case, I have it per minute. They want it in miles per hour. Miles per hour. So I'm going to have to do some converting here, right? So I already have my S over T, and I'm not multiplying it out right now because I'm going to have to do some multiplication when I convert it anyway. All right? So how do I change minutes, or how do I change, what am I in right now? It is inches. So I am in inches per minute, and I need it in miles per hour. I need to do some converting. How do I convert it?
You
can start with either. All right, so let's start with the minutes and change those to hours. How many minutes are in an hour?
60.
So 60 minutes per 1 hour. All right. And I'm going to walk through from inches to feet to miles. Okay. How many inches are in 1 foot?
12.
So I'm going to do that conversion. And then how many feet then are in 1 mile? 5,280 feet. All right. All right, 5,280 feet. So then what you're going to do is you're going to multiply across. You're going to say 1292 times pi times 13 times 60 times 1 times 1. And you are going to then divide it. And you do have to put parentheses here. So in your calculator, when you do this one, you must do, you don't have to do parentheses at first. That's not as important. But basically, you're multiplying 1292 times pi times 13 times 60. And that group is divided by 1 times 12 times 5,280. One thing you do want to check when you do this is that you did all your conversions. So this will keep you from not doing a conversion. You can cancel them out. So my inches canceled out with inches, my minutes canceled out with minutes, and my feet canceled out with feet, and I was left with miles per hour. So here I should round it to the nearest whole, 50 miles per hour. All right, so then the second piece is the same exact thing. We are going to take the 840, or not the 840, that we've already multiplied that one, so we don't have to multiply that again. We're going to take the 1680 pi, that's my theta, times my r, 13 inches, to 1 minute, and we are going to do our conversion. Exactly the same as we did before. So we're going to take this exact conversion, and we are going to do it again with this one. And when you do all of that out, don't forget how to do it in your calculators, but you should get rounded to the nearest, should get 65 miles per hour for that one. And so your range would be from 50 to 65 miles per hour would be your range. All right, trigonometric functions on the unit circle. We're going to start with any trigonometric function at any angle anywhere on the coordinate plane. And we're going to talk about how we calculate this using right angle trigonometry. All right. So if we look at what they've done over here, they have started this angle over here on the x-axis. It terminated over here. And so what's created are these right angles. All right. We've created these right angles. So if this is my angle here, then my base of my angle is x, my height of my angle is y, and the radius is my r. And I can calculate the radius by x squared plus y squared by Pythagorean theorem, right? So I have this right triangle right here that I'm talking about. This right triangle right there, all right? And so if I'm using this angle as a reference, the opposite side is my y, right? Because the length of this guy is going to be y. Everybody see that? The length of that guy is y, because that's how far I went down, all right? And so if I were to calculate based on just SOHCAHTOA, it would be opposite over hypotenuse, y over r, all right? Make sense? If I were to do, based on this angle right here, if I were to do cosine, adjacent over hypotenuse. And so if I were to label this entire angle based on this guy right here, this would be adjacent, this would be opposite, and this would be my hypotenuse, okay? And I could simply do SOHCAHTOA throughout that entire thing based on that, creating that right triangle, okay? So when you do that anywhere on the coordinate plane, you create these 6 functions. It will always work on the coordinate plane. My sine will be my y over my r, y over r. My cosine will be my adjacent, or x over r, x over r. My tangent will be opposite over adjacent, y over x. Ready? You see that? Okay? So my y over r, sine, my x over r, cosine, and my y over x, tangent. And then, of course, we know reciprocals. So cosecant would be r over y, secant would be r over x, and cotangent would be x over y. All right, this works anywhere on the coordinate plane. Now, you may have to calculate your r, okay? They may just give you the x, y, but calculating the r is strictly the Pythagorean theorem. That's how you calculate your r. That is the base, the height, the hypotenuse of a right triangle. To calculate the hypotenuse, Pythagorean theorem. So let's look at the example here. Let x negative 6 be a point on the terminal side of angle theta in standard position. Standard means it's just a positive angle, all right? Find the exact values of the 6 trig functions, okay? They have given me x and they have given me y. I need to calculate r. So my first step here is to calculate r using the Pythagorean theorem, all right? R is going to be the square root, right? Because it's going to be squared, of a squared plus b squared, or my x squared plus my y squared. R will always be positive because you're talking about a root here, okay? R will always be positive. All right, and this stems from Pythagorean theorem, right? Which is my x, my y, and my r. X squared plus y squared equals r squared. So to find r, I take the square root of both sides. So this is how I get r. So I'm going to calculate it. What is 8 squared? And then 6 squared, negative 6 squared is? So I have the square root of 100, so my r is 10. And then I'm just going to do my 6 trig functions. My sine of theta is y over r. What is my y? Negative 6 over 10. I'm going to reduce it to negative 3 over 10. Over 5, not 10. All right, negative 3 over 5, right? My cosine is x over r. So I'm going to reduce that. And my tangent is y over x. And I'm going to reduce that as well. So I have my sine, cosine, and tangent. All right. The other three are simple. We're just going to reciprocate it. Cosecant is going to be the reciprocal of my sine, negative 3. My secant is my reciprocal of my cosine, 5 over 4. And my cotangent is my reciprocal of my tangent, negative 4/3. So when you did this, you should have gotten an r of square root of 5. So your sine is negative 1 over square root of 5. You need to rationalize that. Square root of 5 times square root of 5. You get negative square root of 5 over 5. Cosine would be negative 2 over square root of 5. Same thing, multiply top and bottom by square root of 5. Negative 2 square root of 5 over 5. And tangent would be y over x. Negative 1 over negative 2 is just positive 1/2. Cosecant just reciprocated. And I always go back to this one to reciprocate it. The first one, because then you will have to rationalize it. So when you flip that, you just get negative square root of 5. When you flip this one, you get negative square root of 5 over 2. And of course, when you flip this, you just get 2. So let's look at these common angles here. You have a common angle right here, 0 degrees, right? 0 degrees. Your x is whatever your radius is, right? and your y is 0. So if I'm going out here, whatever my radius is my x, and my y is 0. So if I put my values here, x would be r over r, so my cosine would be just 1. My sine would be 0 over r, that would be 0, right? And so at this point, my x value is r and my y value is 0. When I come up here, my x value is 0 because I haven't gone left or right, and my y value is r. When I come all the way over here, my x value is negative r, and my y value is 0. And when I come way down here, my x value is 0, and my y value is negative r, okay? Because I'm creating a circle, right, with a radius of whatever it is, right? So this point, my radius is r, this point, my radius is r, this point, my radius is r, and this point, my radius is r.
And what about
when then we put this into something like this? Sine of negative 180. So we went this way, and we ended up at the point negative 1, 0. Negative 1, 0. They want the sine. Sine is what? Y over r, yes?
Yes.
Sine is y over r. What is my y value right here on the x-axis? What's my y value right here? They tell me. What is my y value? 0. What is my radius? It's negative 1 because it fell on this point right here. Yes? So that's the distance from my center. So 0 over negative 1, my sign here is 0. How about tangent of 3 pi over 4? 3 pi over 4 falls right here on this axis, right? Tangent is what? Y over x, yes?
Yes.
What is my y value?
-1.
What is my x value?
0.
What's the problem?
Negative,
I'm dividing by a?
negative.
I'm dividing by a 0, right? The tangent of 3 pi over 2 is undefined. All right, let's look at secant of 4 pi. Any even pi, 2 pi, 4 pi, 6 pi is always going to fall right here because that's a full circle. All right, secant is the reciprocal of my cosine. My cosine is x over r, so my secant is r over x. What's my radius here? Distance from 0. What's this distance? That's my x value, right?
4.
My x value is 1. All right. And my radius is 1, right?
Oh, okay.
So my secant here is 1.
I was looking at the 4 pi down there.
So anytime it falls on an axis, your radius and one of your variables will be the same. If it falls on the x-axis, your radius and your x will be the same. Y-axis, your radius and your y will be the same. All right? Now, what happens then is you can solve for these guys. All right? 270, 90, 180, 270. 270 looks just like this, right? This is 270. So I want the cosine of a 270. Cosine is x over r, all right? X over r. Does it matter what my r is? What is my x value on this particular angle? It falls on the y-axis. What is my x value always on the y-axis? 0. So 270 is always going to be 0 over r. So that's always going to be 0. All right? What about this next guy? Pi over 2. Pi over 2 is right here. All right? Right here. What is my x value right there?
1.
X value on the y-axis, 0. All right? My y value,
-1.
+1. All right, if my radius is 1. Okay? Cosecant is the reciprocal of which one?
Your sine.
Your sine.
Which
So,
is r over y.
right. What I know about this is my r and my y are the same thing right there, yes?
Yes.
So I end up with r over y, which are the same things. So anything over itself is 1. All right? Let's look at negative 90. Negative 90. Negative 90 is right here. What's my x value at negative 90? On the y-axis it is 0. And then I have a y value, yeah? Right? What's my cotangent? Cotangent is x over y. Yes, x over y. So that one's going to be, so this one's going to be 0 at negative 90. All right? So what happens then is you can start using some of your common angles because they are always going to happen the same way. All right? They're always going to happen the same way. And so it just changes what quadrant it's in, because plus positive and negative. All right? So if I have an angle right here, and let's say this particular angle is 135. All right, so let's say this particular angle is 135. All right, that means that this angle over here is 45. How do I know that? It's because the half of the circle is 180, right? Does that make sense? So if I have just created 135 here, what's left is going to be 45 degrees because this straight line here is 180. Everybody agree a half circle is 180? Now, what do you notice about the 45 degree angle and the 35 degree angle? Well, their x, y, and r are the same exact thing. It's just that the 135 has a negative x and a positive y, and the 45 would have a positive positive. All right? So what happens with reference angles will have the same sine, cosine, and tangent as their supplement. So what do I mean by supplement? Adds up to 180, right? And so they'll have the same ones, except they'll just have different signs. And so what you can start doing is if you remember the 30, the 45, and the 60, remember I said those are going to be important angles, 30, 45, and 60. And if you know those sines, cosines, and tangents, then all of a sudden you start having reference angles that you can use those for. All right? Because they end up with being the same exact x, y, and r. X, y, and r ends up being exactly the same. And it just changes. So you have to figure out, where does my terminal side end? If my terminal side ends in my first quadrant, my x and y value in my first quadrant is what for both of them? Positive. If it ends up in the second quadrant, though, my x value is negative and my y value is positive. Third quadrant, they're both negative, right? And fourth quadrant, and it actually was wrong in my book. I had to change it. Is it wrong in your book as well? In this last quadrant, it's a positive A and a negative B, right? Positive A and negative B. And so as long as you can figure out what quadrant this ends in, then you can use its reference angles to help you. And so here's where it's talking about your quadrants down here. The first quadrant, positive, positive. Second quadrant is going to be negative, positive, negative, negative, positive, negative. And what you do is you look to the closest x-axis to determine what the reference angle is. So if I'm here, my reference angle is whatever the angle it actually is. But if I fall into the second quadrant, I have to subtract it from 180 to get what that is. If I fall into the third quadrant, I take my angle and subtract 180 from it. And if I fall into my fourth quadrant, I subtract from 360, because that's going to be my closest. So first quadrant is what it gives you. Second quadrant, subtract from 180. Third quadrant, subtract 180 from your angle. Fourth quadrant, subtract your angle from 360, and that will give you your reference angle. All right, so let's look at the example. All right, sketch the angle. I'm not as concerned about you sketching it, but it does give you a little bit of a visual. All right, so if I sketch this angle, 300 is going to fall in what quadrant? Well, it's important to know where your markers are. This right here is 90. This is 180. This is 270. So which quadrant is 300 going to fall in? My fourth quadrant. So that's going to be somewhere over here, right? So I'm going to have to subtract from 360 to get my reference angle. 360 minus 300 gives me a 60-degree reference angle. All right, let's look at the next one. Negative 2 pi over 3. All right, so this is pi over 2. This is pi. This is 3 pi over 2, and this is 2 pi. If I'm going in the negative, this is negative pi over 2, this is negative pi, and this is negative 3 pi over 2. All right? So, pi over 2 to pi, to 3 pi over 2, I need to figure out where this is. Where would negative 2 pi over 3 fall? Get a common denominator, by the way. What's the common denominator between 2 and 3?
6.
So this would be negative 3 pi over 6, right? This guy would be negative 4 pi over 6. Where's he going to fall? If we're going this direction, he's going to fall over here, right? Yes? Yep. All right, so we're closest to this particular one here. And we have to subtract it from that guy. So what do? What is pi? This is going to be 6 pi over 6, right? How far away is negative 4 pi over 6 from negative 6 pi over 6? How far away is it? So negative 4 pi over 6 minus a negative 6 pi over 6. How far away am I?
2 pi.
Or pi over 3. What's pi over 3 in degrees? Do we know? Those are one that you're going to have to memorize, by the way. It's 60 degrees.